Okay, good afternoon, morning or evening, calculus people. Day 3 of the integration unit. So we're going to actually learn about the integration symbol today and look at how we use different notation to do antiderivatives. It's called integration. And we're going to do integration of the power rule, basically, first. Okay, so we're waiting for our Blackboard to pop here. We'll get going on what we're going to do today, and we're going to do a couple of things today. We'll look at the integration symbol, what it means. We'll look at the notation that we use, okay? And then we'll look at the power rule, and then we'll do some examples using the integration symbol. So it's like the antiderivative, but now we're going to have some symbolization in there as well. Okay, so let's get this set up here. Okay, so today's day 3, the last unit. And we're in the and today we're going to be looking at the integration or integral symbol and notation. And then we will look at the power rule. We already know it, but we'll look at it again, and we'll do some examples. Okay, and then do some practice as well. Okay, so let's go ahead and look at starting with the integration symbol and notation. Integral notation. So I got to use the marker for this mainly. Okay, so when we're doing integrals or antiderivatives, we use this symbol here that looks, let's get this, let's do it in blue today. Okay, so the integral symbol kind of looks like this. Okay, that's a symbol. It's not double hooked like that. Boy, let's get this neater here. Okay, so that means you're going the opposite direction of a derivative. So if you have y equaling 2x cubed minus 4x squared plus 5, okay, we know that the derivative of this is 6x squared minus 8x. Okay, and we're going to use this example in the notation. So if we're going to go from, we're going to go from y prime to y. And we're going to use dy dx notation now, because it helps us. Okay, dy dx means the derivative of y with respect to x. Okay, so if we write it like this, let's start off, instead of putting y prime there, let's go dy dx equals 6x squared minus 8x. Okay, now if we want to write that in integral notation, okay, we can also write this as a factor. We can cross multiply this out or multiply this out on this side. So we can rearrange it to say that dy equals this whole thing times dx. And this is the notation that we're going to use to do integrals. We're going to say that dy equals this dx. So if we want to go back to y, if we want to integrate this to y, so we take the integration symbol of dy, and that's going to be the integration symbol of this whole thing dx. So this is going to this tells us that we're going to integrate back, do the opposite of the derivative. We're going to turn this back to y, and we're going to turn this back into whatever it would be. So now we just use this integral symbol. We just use antiderivative rule for power rule. Okay, so the antiderivative, use the power rule. Okay, so if you can't remember what the power rule was, the power rule is if you have dx dy is equal to x to the power n, then y equals, okay, x n plus 1 divided by n plus 1 plus c for our constant, because it might have a constant in there as well. So that was the power rule of the antiderivative. So we're going to go ahead and use that now in our to do our integral here. Okay, so we are going to integrate. The integrating of this is just y, because it's just dy, equals integration of this. That's going to be 6x squared 2 plus 1 is 3 over 3 minus 8x okay, 1 plus 1 is 2 over 2 plus c for the constant. Okay, so if we reduce this down, we get 2x cubed minus 4x squared plus our constant. Notice that it's not exactly what we had up here, right? Because we don't necessarily know what the constant is. So this is why we call this an indefinite integral. This type of integral is called an indefinite integral. Okay, indefinite. See if I can spell it right here. Okay, indefinite. That's because we don't know what that constant is when we go back to the y. Okay, we could figure it out if we get some more information, but in this case, we don't necessarily have it. Okay, so that's basically the integral way that we write out integrals. So let's do a couple practices in doing some integration. Okay, so let me just get my list here and we'll do some practice questions. Okay, so when working with integrals, we're going to do a few different examples. We're going to do straight integration with the power rule. We're going to do rearranging first and then integrating. And we're probably going to do, well, those two for sure. And maybe if we have time, expanding and then integrating. Okay, so we'll do those three types. Okay, so we'll do that on the next page here. So these are going to be, when working with indefinite integrals, okay, we often need to simplify or expand the expression to use the power rule. look at some examples. So the first time is just straight integration. Yeah, so let's do some straight integration examples. So let's say we had, okay, now often they'll leave out the y part. They'll just write it like this. They'll go integrate 3x to the fourth plus 2x cubed dx. Okay, so if we're going to integrate that, okay, so we do the integration, we just use the power rule. So y equals, because we're assuming we have integration dy out here. Often that's not written, that's just written like this in short form. So we go 3x, 4 plus 1 is 5 over 5, plus 2x, 3 plus 1 is 4 over 4, plus c. Okay, so this is going to end up in, if we reduce it down a little bit, 3/5 x to the fifth plus 1/2 x to the fourth plus c. So that's just straight integration. Okay, we know how to do the antiderivative rule. It's not too difficult. It's just written in this type of form when we're doing integrations now. Okay, now let's take a look at simplifying first before integration. Okay, so what happens when you get examples where, like in B, we're going to simplify first before we integrate. So let's do an example like that. Okay, so this would mean something that looks like this. Okay, you might have to do some rewriting of the thing or anything like that. So let's say we have the integration of (3 minus x squared root x dx). Okay, so we have to kind of rewrite this as a power. So if we're doing that, this is going to be integration of 3 minus x squared times x to the 1/2 dx. So we can use the rule that we have, okay? Okay, when you're multiplying exponents of the same base, you add the exponent. So that would be exponent rules. 3 minus, well, this would be x to 2.5 power, or 5 over 2 power. You often write it as an improper fraction, dx. Okay, and then now that we've kind of simplified it, so there's only one x in there, we now can use the power rule to integrate it. So y equals 3x over 1, which we don't have to bother with, okay, minus, okay, so this is where it gets a little tricky, x, okay, 5/2 plus 1. 5/2 plus 1. 1 is like 2 over 2, so this would be 7/2. 5/2 plus 1 is 7/2, divided by 7/2 plus c. So we got to do a little bit of rearranging there. So y equals 3x. Okay, when you're dividing by a fraction, you multiply by the inverse, or sorry, not the inverse, the reciprocal, pardon me. So that's 2 over 7 times x to the 7/2 plus c. Okay, and that's our indefinite integral as far as we can go there. Okay, let's see if we can get another one here. We'll do another one like that. So let me pause here and dig up another one. Okay, got another one here that we can try. Again, we're going to have to simplify before we integrate. Okay, and we'll use power rules again. So let's say we had integration of 3 over x squared plus 5 over x to the 4th dx. Okay, so we have to rewrite these as powers. So this would be like the integration of 3 to the power of x to the power of -2, because if we bring it up, we have to change the sign of the power in the exponent rules, and this would be plus 5x to the power of -4 dx. Now we can just apply the power rule again. So again, power rule is going to be adding 1 and dividing by that as well. So y equals, okay, 3, -2 plus 1 is -1 over -1, plus 5, -4 plus 1 is -3 over -3, plus our constant. Okay, so there might be a roots in there. Okay, if we simplify that down a little bit, this is going to be y equals -3x to the power of -1 minus, because this is a minus here, 5/3 x to the power of -3 plus c. Okay, and that's a nice answer there. Or if you wanted to rewrite it so that these are positive, or you could write it like this: -3 over x, put it on the bottom, minus 5 over 3, and then put that on the bottom, x cubed, plus our c. Okay, so that's a good way to answer it. That's another good way to answer it. That's a 3 there, cubic. Okay, so there's a couple of those types. Okay, so the other kind of example that we can have is expansion. What if we have to expand before we can integrate? So let's do an example or two like that. Okay, we're getting up in there. So let's say that we have something like this, expanding before integration. So something that would look like a few examples here. Let me get my examples out here. And then we'll do some practice after this. I'll keep this to a 20-some minutes, and then you can have 20-some minutes for practice in this one. All right, so let's say we had the integration of 2x minus 3 cubed dx. Okay, so we can't do any, well, we haven't learned any sub methods yet, but or anything like that. So what we have to do is we have to expand that out. So this is 2x minus 3 times 2x minus 3 times 2x minus 3. So okay, so let's do the first part. So if we multiply those ones up, it's going to be 2 times 2 is 4. So we 4x squared minus 12x plus 9. Okay, and we still have one more of those to multiply out. Okay, so we just have to expand this whole thing out. So do the first one. So 2x times 4x squared, 8x cubed. 2x times negative 12x is minus 12, or minus 24, pardon me. can't multiply here today. 2 times 12, negative 12 is negative 24x squared. Okay, plus 18x. Now we do the negative 3, negative 12x squared plus 36x minus 27 dx. Okay, so we can do a little bit of simplifying down in there. Okay, there's 1 cube only, 8x cubed. The squares can go together. Negative 24 and negative 12 is negative 36 squared. X is squared. 18 and 36 is 54. And then we have a negative 27. Dx. Okay, now that we've got it all expanded out just into numbers and powers, with only symbols in between, adding and subtracting, so we can now change it back to a y. Y equals, okay, we use the antiderivative power rule or the integration power rule. 8x, 3 plus 1 is 4 over 4, minus 36, x, 2 plus 1 is 3 over 3, plus 54, x, 1 plus 1 is 2 over 2, minus 27x over 1 plus c. Okay, we can do a little bit of simplification here. This would be 2x to the fourth minus 12x cubed plus 27x squared minus 27x plus c. Okay, so there's a couple examples. Okay, well, one example of that expansion. Okay, so that's about 20 minutes, 22. I'm going to pause. I'm going to pop up the practice and show you that. And that's what we'll work on as well. Okay, so this is what you'll be able to work on here. As you can see, there's lots of them. You don't have to do all 21. Okay, there's some, let's just kind of go through some that might, okay, we've done lots like that. This one here, just a constant right there. This one is just dx. Okay, this one here, you have to use power rules to simplify what that would be. Same with this one, power rules. Same with this one, power rules for exponents. Okay, here we have to do some division. Okay, so you'd have to divide them all out and see what they would be. This one you'd have to expand. Okay, this one's good. This one's good. Okay, this one's okay, good as well. Okay, here we'd have to rewrite this one, rewrite this one, rewrite this one. Have to expand this one out. Okay, have to divide this one out, have to divide this one out, have to divide this one out. So maybe we should do, not all 21 of these, but try a few and the answers will be provided as well. So that's what you'll do for, do like every third one or so, or every second one, and do a few practices. Okay, and we'll get into, after this, we'll get into some of the sub rules that come with integration next. Okay, see you tomorrow.